Welcome to Chapter 7.5, Understanding Slope. So slope, when we talk about slope, we're talking about the steepness of the line. A line can be very steep. A line can be fairly shallow. Lines can even be vertical or horizontal, and we will talk about all of these today. If you look over here at my two examples, we see positive and negative slope. So we always talk about slope going from left to right. And then whether it's going up or down is what matters. So when I'm going from left to right, I see that this is increasing, or my slope is going upwards. That is a positive slope. However, if we look at this line, I see that again, moving from left to right, I'm moving what appears to be down, and this is a negative slope. Let me redo that in a little bit of a darker color. So left to right, going downwards, again, is a negative slope. So our other vocab word for today is rate of change. Rate of change and slope are often used interchangeably. Rate of change is often used with a table or with a real world scenario, but they're talking about the same thing. So slope, we find slope by finding the vertical change over the horizontal change, or the rise over the run. Okay, this is really important. Rise over run. So let's take a look at how this actually works. Example 1, find the slope of the line below. So we just said that slope was equal to rise over run. So if I look at this example, I see that I have 2 points. Point A is at 2, 1, and point B is at 5, -3. So first we're going to talk about simply counting. So my rise, I see that moving from left to right, and we always move from left to right. I see that my line is going downwards. So to get from point A to point B, first I'm going to go down. And if I count the lines, I'm going to go down 1, 2, 3, 4. So my rise is going to be -4, because remember, when we move in this downward direction, that is a negative slope. So my rise, down, -4. Now my run is always positive because I'm always going to move from left to right. So my x-axis numbers are always getting bigger. So I'm going to run 1, 2, 3. So the slope of this line is -4 thirds, or -4/3. Down 4, right 3. It is okay to leave as an improper fraction. Do not convert it to a mixed number. Okay? That's a no-no. We're going to leave it as an improper fraction, because what that means is I'm going down 4 and to the right 3. So let's talk about what this looks like mathematically. So my rise is the change in my y values. My run is the change in my x values. So I'm going to start with 1 point. and subtract the other. Order doesn't necessarily matter as long as you do it the same way the same time. So I'm going to do point B minus point A, just to keep that in mind. So my y value in point B is -3. My y value in point A is 1. So -3 minus 1. Let's make that a 1. Over my change in B values, my change in X values. Again, B minus A. So 5 minus my X value in point A is 2. And then I'm going to solve. So -3 minus 1 is the same as -3 plus -1, or -4. And 5 minus 2 equals 3. And I get the same answer as I got by counting. So you can count, or you can use the formula, or you can do both to check your work. So let's look at a couple of special cases. So let's talk about example 2, part A. This is a horizontal line. So if I use the slope formula, rise over run, I'm going to call this point A, and I'm going to call this point B. So I'm going to do B minus A again. So my y values, remember that ordered pairs are always x comma y. So 2 minus 2 over 3 minus -2. Well, 2 minus 2 is 0, and 3 minus -2 is the same as adding the opposite, which becomes 3 plus 2, which is 5. Well, if I have a pie that's cut into 5 slices and I have none of those slices, that means I have no pie. It all got eaten, and I'm sad because I have no pie. So the slope of any horizontal line is 0. Flat line, 0 slope. If I put a marble on that line, it's not going anywhere because it's completely flat. Horizontal, slope of 0. But now let's look at my vertical line. So again, rise over run. And I don't really have a left and a right because the 2 points are on top of each other. So I'm going to go with top and bottom. So we'll call this point A. We'll call this point B. So I'm going to do point B minus point A. So I have -2 minus 1 over -5 minus -5. Well, 2 minus 1, I change it to adding the opposite. So that's -3. And -5 minus negative becomes adding the opposite. And -5 plus 5 is 0. But if my whole is 0 and I have -3 things, how does that doesn't make any sense. And you're right. A vertical line is called undefined. It's not possible mathematically to have 0 as a denominator. So we call the slope of a vertical line undefined. So these two things are really important to remember. Okay. Example 3, let's put this to use in real life. So graph the fuel usage data at the left, connect the points with a line, then find the rate of change. So they've already created the table for us. So the miles traveled is my X. Fuel used is Y. Tables are always written that way. So, of course, we put our units or our labels. Miles traveled, fuel used, and you're going to write yours more vertically. I just can't do it very well. In gallons. So miles. All right, I see I'm counting by 40s, but I start at 80. Well, all right. So 40, 80, 120, 160. This line out here, if I had another one, would be 200. Let me fix this. That actually says 160. 160. Okay, and fuel used. Well, let's see. I see that we're counting by twos, but we're starting at 4, so we'll count by twos. 2, 4, 6, 8, 10, 12. Okay, sure, that'll work. And now I simply plot my points. So 4 gallons, 80 miles, 6 gallons, 120 miles. Oh, nope, that goes there. Okay, and it's really important when you're graphing that you're really being careful and paying attention. 160 miles is 8 gallons. 200 miles is 10 gallons, which would go there. And I'm going to connect the dots. Now your dots will be very neatly connected. Mine will be sort of connected because I don't have, there we go. And this can continue on. So we're going to put an arrow on the end. However, it cannot go lower than 0, 0 because I can't have negative gas and I can't travel negative miles. So there's no arrow on this end. It's like a ray, but it can continue on this way. The more fuel I use, the farther than I travel. So here's my graph. So rate of change. I can use my graph and I can pick 2 points and I can say, we're going to pick these 2. I'm going to go, okay, I'm going to go my rise. What am I rising? So my rise, be very careful. Notice, well, yes, I'm going up 1 graph line. That actually represents going from 4 to 6. So that's actually a rise of 2. Okay, it's about the numbers, not about the placement. The run, I'm going then from 80 and I'm running to 120. So that's a run of 40. So my rise over run is 2 over 40, which I can simplify to 1 over 20, which means 1 gallon for every 20 miles. So let's look at that doing the table. So I see here in my table, I have a rise going from 6 to 4, which is a difference of, actually, let's turn that around. So it's positive. Going from 4 to 6, which is plus 2. And then going from 80 to 120, which is plus 40, or 1 over 20. So I can use my table, or I can use the graph to find the slope of a line. Okay, that's it. Your turn.